What's up, skeptics? Welcome to another episode of Reason to Doubt, your source for all things skeptical. I'm Jordan, joined as always with Jared, and we are going to kick off this new year, 2024, the same way we kicked off last year, 2023, with everyone's favorite tablecloth, the Shroud of Turin. It's been a year since we have recorded like a deep dive into this topic, and since we did the last one, which was way more popular than we ever expected, we've kind of become the de facto Shroud of Turin guys somehow, and so we thought
Shroud of Turin skeptics.
That's true. The Shroud of Turin skeptics, not Shroudies, but Shroud of Turin skeptics. And turns out that this cloth is a big deal for a lot of people. And no part of this entire field of research is more controversial than the radiocarbon dating, partly because it strongly points away from the relic being authentic, meaning that it actually wrapped Jesus up when he was dead. That's what authentic means. Yeah. So since we released our original episodes, we've gotten just an endless barrage of comments about the radiocarbon dating. Most people insisting it's been debunked, that we should throw it away. Some of those comments from people who maybe should know better. So we thought we would dive back into just that. This is going to be a multi-part series. In this first episode, we're going to be talking about the radiocarbon dating itself. What is radiocarbon dating? What is this specific instance of it? We'll talk about the flaws because it is flawed in some ways. And given what we know about it, what can we possibly learn from the carbon dating and what we can't know from it? And the features of it that any possible hypothesis that wants to explain it, what will they have to address? What kind of facts do they have to explain in order to be successful? And then,
real quick though, when we first started this, our very first introduction to the Shroud of Turin was just a response video to something we saw on YouTube, and we weren't trying to be serious, and people berated us for not taking it seriously. So then we took it serious and we did some in-depth things, but apparently that wasn't in-depth enough. So now we're going to go back and we're going to go even more deeper into the weeds and try to address all of this stuff, right? But there's certain things that we're not going to be talking about in this episode.
Right. This is going to be only about the carbon dating. So we're not going to be talking about how the image was made. We're not going to be talking about any pollen that was on it. We're not going to be talking about artwork or anything like that. This is purely on the carbon dating. If you are interested in those things, we have talked about those things elsewhere. So we'll leave a link in the description, 2 episodes on those other things if that's what you're interested in. But here, for this episode and for the further episodes in the series, only carbon dating. So after this episode, we'll be tackling these specific explanations that have been posited for the carbon dating and the results that are there. Some of which would indicate that it's authentic, if they're correct. Some of which would indicate it is not authentic. I believe we're going to do one episode purely on the irradiation hypothesis of Bob Rucker, but I won't promise that. We're going to spend as much time as it takes to give every hypothesis that is popular its due. So this will be like a one-stop shop. Well, several stops, could be several episodes, but one location for all of your radiocarbon needs.
Yeah, but we should first start, in case this is your first foray, your first exposure to the Shroud of Turin, is by starting to say, what exactly is the Shroud of Turin? Why is it so popular, and why is it so controversial? So we should just start with that.
Of course. Always somebody's first episode. If it's yours, make sure you drop a like, subscribe, so you'll be able to see the rest of this series because it's going to be very useful to you. And veterans of the channel who already know this stuff, there'll be timestamps in the description. Feel free to skip ahead. But the Shroud of Turin is a length of linen that is 4.3 meters long by 1.3 meters across. And so on it, you can see it on the screen. There are faint brownish images of a naked man, the front and back. So in the image, they're side by side. In reality, it's like one continuous piece of cloth, and it's as if the body was like sandwiched between the two pieces. Front and back would be covered head to toe. Sort of like this other way, that's how they would have laid it, allegedly. So the man on the cloth is almost certainly supposed to be Jesus of Nazareth. Regardless of whether it's authentic or not, I don't think there's much controversy in saying this is supposed to be Jesus.
Yeah, it doesn't literally say this is the image of Jesus on it. But.
Right. There's no like Jesus tattoo or anything on the body, but I mean, it's pretty obvious who it's supposed to be. Now, some people think
Side note, real quick. I think you mentioned earlier about a tablecloth. We should maybe try to make some table runners for like Thanksgiving, where you just like eat and you have the table runner, and it's just a Shroud of Turin. Like that would be pretty awesome.
I'd be shocked if that doesn't already exist, but just in case it doesn't, leave in the comments whether that's something you would be interested in, because we could make this happen if it's actually something you guys would be interested in. If you want your own, like, we could do a whole line of like,
I mean, you can sell them to
tablecloth
churches. So like when you're eating the Eucharist, like you just,
on Jesus, just body of Jesus from the body of Jesus. Right? You could like cover it. You could like cover it with the crackers. You could cover the body with the body. Yeah. Yeah.
Yeah, this is all right. Let us know if you want us to do this. Sorry.
So some people think that this image was left as evidence of like a miraculous resurrection. These people who think it's authentic and usually think it's evidence of some kind of miracle, they are often known as shroudies. That's how we'll be referring to them. It just means someone who thinks that the burial cloth, the Shroud of Turin, is in fact the burial cloth of Jesus. That's what that means. Yeah,
and shrouded isn't like a derogatory term that we've come up with. This is something that they will call themselves on the internet. Some people will use the term syndenologist as somebody who studies the Shroud of Turin. So we're not trying to like poke jabs at them.
Right.
Although I do think the name is kind of funny, but it's
the one they've claimed for themselves. So don't come at us. That's them. Anyways, so shroudies see. Obviously, we disagree with that assessment. Otherwise, we wouldn't be making this episode, or the episode would be very different anyway. So shroudies claim to see reports of the shroud existing throughout history. Like they will point to things going back to the 1st century. But the uncontested history, the history that nobody disputes, is that the shroud shows up in history in 1352 in France when it came into possession of one Geoffrey, I'm going to butcher the pronunciation, but Geoffrey de Charnay, a French knight. And he was like the bestest knight ever. People loved him. And since that time, in 1352, the shroud has been stored in several places. Some of those places caught on fire. So it's been burned, it's been smoked, it's been touched, fondled, patched, repaired. It has a very lively history. In the modern day, of course, it's kept in Turin. That's why it's called the Shroud of Turin. And it's been studied by dozens of scientists, though only a handful of them have actually been able to touch the relic itself. It's a holy relic. The church owns it. And so you can't just like go do whatever you want to it, right? Most notably, the Shroud of Turin Research Project, or STURP, they had a week with the relic in the late 70s. They published a bunch of papers. They were unable to figure out how the image was made, but they concluded it wasn't dye or pigment. Again, we're not going that. This is just background in case you don't know what the shroud is. But after that, though, after that history of the shroud, after STURP was done, another group came in and did carbon dating. And so that's what. So now you've been brought up to the present day. Okay.
But Jordan, what is carbon dating, and why should I care?
Okay. Well, first you take some carbon, and then you like look at it and see how old it is.
That's it.
That's it. That's all there is to it.
Oh, cool.
But we can get into a little bit more detail, I guess. So carbon dating is a type of radiometric dating. Specifically, it measures how much radioactive carbon-14, that is present. It measures how much is present in your sample of a once living organism to determine when it was last alive. So your thing must have been alive at one time for this to work. In the case of the shroud, it's made of plant fibers, flax, that was once alive. So you'd be seeing when the flax that the linen is made of, when that was killed, basically. Carbon-14 is, like I said, radioactive and is produced in the atmosphere by cosmic radiation. So cosmic rays are coming in, there's an interaction, turns what's already up there into carbon-14. That carbon-14 decays at a steady, predictable rate, has a half-life of 5,730 years. So in that amount of time, half of the carbon-14 in your sample will have decayed back into nitrogen-14 via beta decay. So one of its neutrons turns into a proton and an electron, and they kick the electron out. That's what happens. It's also in the atmosphere produced at a predictable rate. So at any one point in time, we know about how much carbon-14 is in the atmosphere, and by extension, we know how much is in all of us. So plants absorb this radioactive carbon, when they absorb CO2, and then animals eat plants, and then we eat those animals, and the whole circle of life cycles around such that you're about the amount of C14 in you is about equal to the amount in your atmosphere. But when you die, you stop breathing and eating. And so you stop taking in new carbon. So the carbon in your body is decaying. right now, it's decaying and irradiating you, right? But as fast as it's decaying, you're taking more in. But that process stops when you die, so it'll just start going down. Okay, so if you know how much was in the thing when it died, you can measure how much is there now, and knowing how fast it decays, you can see how old it is.
So if I just go to like a buffet and just eat all day, can I just store up on carbon, like get a bunch of extra carbon in me?
Well, you get more in absolute terms, but it's the ratio of
Right.
radioactive carbon to not radioactive carbon is one of the things that's measured. But so there's a lot more that could be said about radiocarbon dating, like fractionization and calibration curves and all that jazz. That's what I've gone over is enough to understand everything we're going to talk about with the Shroud of Turin. If you want to know more, there's videos by experts on that. Okay. So back to the Shroud of Turin. Like I said, linen derived from a flax plant, so it is an appropriate material for it. Some people have often asserted that you can't use radiocarbon dating on like textiles, but I looked around just to check this. Beta Analytics is they do this thing for a living, and they listed linen as one of the most common materials that they test, along with bones and woods and shells. So clearly, they don't have a problem for it. But a critical part of the process when you're testing anything, but especially textiles, is cleaning the sample to make sure you aren't accidentally measuring the carbon of something that's not intrinsic to the sample. Okay. Now, this is very important to the Shroud specifically, so I'm going to emphasize it again. Remember, all biological material on Earth has C14 in it. And that's true whether it's a linen burial shroud or a medieval monk's finger oils or the mustard from your sandwich. All of that has carbon-14 in it. So if your sample were to be contaminated with material from a time other than when it was from, and that contamination is not removed, that would skew your test results. So if you had a sample and you took some modern stuff and you rubbed it on your sample, then didn't clean it off, then the sample would appear to be younger than what it actually is, because it would have more carbon-14 in it on average, right? Likewise, if you had a sample and then you rub some ancient stuff on it, it would look older than what it actually is. Okay? So and not only does that effect happen, but the younger the contamination, the more closer to the present the contamination is from, the more impact it will have on the sample, because the decay is exponential. So
yeah, so it's higher concentration, and so
right. So, and by the same token, the older your sample is, the more sensitive it will be to modern contamination, because it doesn't have very much to begin with. So if you have this much and you add this much contamination, it's, that would matter.
It's hard to see. Yeah, that much.
Exactly. Yeah. Right. Okay. So all of that's going to be relevant later. Now, in case you didn't believe me or Beta Analytic about testing linens, I looked for some peer-reviewed research. In March 2023, Margheriti et al. Published radiocarbon dating of archaeological textiles at different states of preservation. They published that in Heritage Science, which is like a journal that Shroudies love. They publish in it all the time, so hopefully it'll be accessible to them. They concluded that carbon-14 dating is a particularly useful tool for for textile studies. They had two caveats. The first was that it's not as good as like testing wood or something, so that's just the nature of the beast. And pre-treatment, like we said, is especially important. Okay, so that's radiocarbon dating in several nutshells.
So when it comes to the Shroud of Turin, then, I mean, you just go over to the Turin and say, hey, can I get a sample to test it? Like, how does that work?
You actually just like go to the gift shop and they just cut off a piece right there and hand it over to you. Yeah. So, no, there was a lot of back and forth after the STRP team did their thing. People wanted to run additional tests. One of those additional tests was going to be radiocarbon dating. And there was a whole kerfuffle between the STRP team and the labs. The labs thought the radiocarbon dating test was more important. The other people had different opinions. They argued for years about it. Eventually, test procedures were published in the journal Nature, MS Tite, Turin Shroud, Nature 1988. And what they concluded was only radiocarbon testing would be done. The samples would only be taken from a single location on the cloth. So when you're going to test something with carbon dating, you have to destroy part of the thing, because you're going to have to take...
destructive process, right?
It's a destructive process. You're going to take some of it, and you're going to burn it and like carbonize it, turn everything, like get rid of everything, and then run it to your detector. So there's no more left at the end. So whatever you cut off the test, it's gone. right?
Yeah. And you can understand why if somebody feels like this is actually a holy relic and was the burial shroud of Jesus Christ, and then is proof of the resurrection, why you might not just want to cut the whole thing up, right?
Exactly. It's understandable why they'd have some hesitation. In fact, one of the reasons radiocarbon dating was done when it was, rather than previously to that, is because new procedures, new technology had come out that would require far less material from before. So before it would have taken big chunks. With the new technology, they required much smaller areas.
Okay.
So the testing procedure, they were going to take all their samples from a single spot, way down on the bottom left-hand corner, quote, away from any patches or charred areas, end quote, and it was going to be under the supervision of a textile expert. Each lab, they picked 3 of them, would be given 40 milligrams of material, and they would also be testing known age control samples. And the labs were not supposed to collaborate until they were all done.
So this is what was published in an article prior to them even doing the thing. So they're kind of laying out like, hey, we realize this is an important thing. We probably only have one shot at this. We want to make sure we get it right. So they're kind of thinking through some of the things they need to look at. Because if you've seen the pictures, we could pop one up here. The shroud is a mess. Like
there's patches burn marks, and burns and everything, right?
Everything, yeah. So it makes sense they would want to do that.
Now, I will say, though, there was controversy even at the time about the plan they published because it was a deviation from what had previously been talked about and what would be ideal. So there were a couple, really 2 controversial changes. The first was that they were all going to take their samples from that one spot because it would be better if you took it from a variety of spots, right? Because if there was something wrong with one spot, but you got your samples from all over, it'd be less likely to be a problem, right? So that would undoubtedly have been a better method than what they ended up choosing. But as we mentioned before, you can understand why the church might be reluctant to let you carve chunks out of Jesus' nose or whatever, you know? So that was one controversy. The other one is the blind testing or lack thereof. So the hope originally was that it would be a blind test so that the lab wouldn't know whether they were testing the Shroud of Turin or anything else, right? That would be ideal, right? And they didn't tell the labs when they handed them the samples. They said, this is sample 1, 2, and 3. They didn't say like which one was which, right? But the shroud has a very distinctive weaving pattern compared to the controls they were being given. So anybody testing it, if they looked at it, they could tell which one they were testing. They considered shredding it into little pieces, but they determined that you could still tell which one was which, and that would make it way harder to prepare and clean thoroughly. And they decided that the making it easier to clean and prepare was more important. So they said, quote, accepted. They had to accept that blind tests depended ultimately on the good faith of the laboratories. So maybe they did a good job with it, maybe they didn't, but that's the way they did it.
So ideally, you would want a blind test where you could give a control sample, you could give this, and then you say, hey, here's 2 samples, test them, tell me what you get. They would test both, and like one would probably be a new, one would be old, right. And then you could compare them.
Now, I will say, up to this point, most people, the thinking, if there was going to be a bias, I would think the bias would be towards the 1st century, because this was like, as we'll say later, they eventually came to the conclusion of the radiocarbon dating was that it was medieval, and that was like a bombshell result, right? So my guess would be, to the extent that there was a bias, it would be a bias towards authenticity, but that's just my own personal opinion. There were 3 labs, though: the University of Arizona, the University of Oxford, and the Federal Institute of Technology in Zurich, and we'll call them Arizona, Oxford, and Zurich from here on out. They were chosen because those are the 3 that used the new, at the time, though now thoroughly vetted and common technology of accelerated mass spectroscopy, AMS method, and that's the one that required a lot less sample to do their thing. So they needed like milligrams of sample, whereas the other one would have required grams of sample.
Yeah, and as a result, these labs are probably some of the most high-tech and cutting edge at the time as well.
Right. So they were using the latest and greatest technology at the time, which again, at the time was relatively new, but now is completely standard. Though labs have greatly improved in the intervening years. I mean, it's been 40 years since this was done. Labs are way better at it now than they were then. But anyway, so the day came when they were going to execute this plan. The shroud has like a backing cloth that's been attached to it. So they separated it from its backing cloth. They cut the place where they were going to cut it under the supervision of 2 experts in textiles. The entire affair was photographed by Barry Schwartz And that's probably the thing he's most well known for. That, and he runs Shroud.com, which is like a repository for Shroud of Turin stuff. So if you look at the Shroud of Turin and you look all the way at the lower left-hand portion of the cloth where that light rectangle is, that's where not the rectangle itself, but that's the area that the samples were taken from. This is a zoomed in picture from a paper, and it shows an overlay of the samples themselves where they were cut. So you notice that going from the bottom part, that's the edge of the cloth. Moving up would be moving towards the center of the cloth. At the bottom, there was the reserva, a reserve piece, which is still in Turin, I believe, that is being saved for something in the future. I don't think it's been used for anything. Then you had Arizona 2, Oxford, Zurich, Arizona 1. Arizona was given 2 pieces because their top piece was a little light. So they were given that second skinnier piece, right? But the order is important. Going from edge to top, Oxford, closest to the edge, then Zurich, then Arizona. The labs did their testing. They tested their controls. They published the results in Nature in 1989. And the result was that the flax from the Shroud dated from 1260 to 1390. So somewhere in that time period. Definitely far away from the first century.
Remind me again when the Shroud first appeared. Like, wasn't it around 13 something?
It was. Its undisputed history, remember, starts in France in 1352. Okay. So it
like the dead middle of what they're predicting, the carbon results.
I mean, in the middle, and you imagine like the Shroud existed prior to it showing up in history.
Right.
And the flax itself would have existed prior to that. So yeah, like strangely enough, the undisputed history shows up right when the carbon dating said. What a coincidence. What are the odds, right? What are the odds?
It must be pretty high odds because as we're going to get into, so.
Crazy. Anyways, though, this was not persuasive to Shroudies who didn't take this lying down. And there were some who have done interviews who said that they read these results and knew that they could not possibly be true because the Shroud of Turin was definitely authentic, and then they sought out to prove that was so.
Starting with your conclusion and working backwards.
Always the best way, because then you know you're going to find the right answer. So
always.
Right. So gallons of ink has been spilled to explain how this cloth that is from the 1st century could have yielded a radiocarbon date from the 14th century. And unfortunately for everyone, but maybe fortunately for us in our subscriber count, errors have been found in this carbon dating. So they dug hard and they did find legitimate errors. So in 2013, the paper Regression Analysis with Partially Labeled Regressors, Carbon Dating of the Shroud of Turin. What a title. Like it just rolls right off the tongue. Amazing. That was published in Statistics and Computing by Riani et al. And in this paper, they noted that there was something funky between the 3 different labs. So this picture, which is not from that paper, it's from Casabianca 2019, but it's the same data. This highlights it well, I think. What you can see here are the ranges of data, what was published in Nature and the raw data, which was later released. We'll get into that in a bit. And you can see like the range that they covered for the 3 labs. You can see that Zurich and Arizona, they overlap pretty well. Their averages aren't lined up, but they overlap a lot. Oxford doesn't quite overlap with Zurich, and it's a little further away from Arizona. So Oxford's kind of over on its own. The other 2 are to the left, right? And the bottom, those are ages before present. So Oxford actually had it being a little older than the other 2 labs. A lot of times you'll see these same results in a different image like this one, where you see it plotted in a line. And you can see the average dots, but the dots of the different measurements that are published in Nature, but the average goes in a slope. Okay. I think that this kind of obscures the overlap between Arizona and Zurich, so I prefer the first image, but both images are the same data.
Yeah, if you look at the linear one, it clearly looks like Zurich and Arizona have no overlap whatsoever on that.
If you didn't know what the dots mean and you just looked at the line, you might come away with the wrong conclusion. So I don't like it. The reason that people use that is because they want to emphasize that there's a trend in the averages going from the edge of the cloth towards the center. And so I'm not saying this data is wrong. It is not wrong. It's the same data.
Presented in a way that makes it look a certain...
Yeah, I think it's less clear than the other one. Regardless, the important thing is that Zurich and Arizona overlap mostly. Oxford doesn't quite overlap, but it's close. It's not like way off on its own. Okay. So Since the dating was done, Shroudis have pointed to the errors that are found. And I'm about to go into a paper that highlights these errors. But before we do that, errors have been found. And because errors have been found in these test results, what you will often hear is, well, it's flawed, therefore you should throw it away. You shouldn't look at it all. You should just set those aside as if they didn't exist and then move on. It should be given no evidentiary weight. And I strongly believe that is a mistake. I think that just because something is flawed, you have to know why it's flawed and how it's flawed to tell whether it is of any use. For example, imagine that you had a stick that you were measuring and you had 3 different rulers that you were using, right? One ruler gave you a result of 1 meter plus or minus 0.1. The next one's 1.1 plus or minus 0.1. Next one's 1.2 plus or minus 0.1. Well, those results don't overlap. Right? The third one and the first one, they don't overlap. There's some kind of problem, right? But that doesn't mean that the stick is just as likely to be 1 centimeter long as a meter long. Well,
right.
obviously,
it's right around a meter. Yeah.
Right. Yeah. Obviously, even though there's a flaw, there's something wrong. That's some evidence that this thing isn't this long, right? Like,
right.
It. Yeah. So just because the results are flawed does not mean they are useless. It just means they're not as useful as they otherwise would be. So to address the Shroudy allegation that we should throw these results away, to debunk that, I'm going to go into a deep dive into a particular paper that outlines the way in which it is flawed so you can understand the nature of these errors, and then we can explain what we can learn and what we can't. Okay? While we know the relative locations of the samples, so we know like where Zurich's patch came from compared to Arizona's compared to Oxford's, right? That picture from earlier. The location of the subsamples wasn't known. So they didn't just take the whole chunk and throw it in the thing. They cut it into smaller pieces to test, right? And so we know that Oxford cut their thing into 3 pieces, but there are many ways to cut it into 3 pieces. They could cut it into 3 rows this way. They could cut it into columns this way, et cetera. So if you look at this picture of one of the labs had 4 samples, there's different ways you could do 4 equal samples, right? These are some of the ways. So it's important. This is what Riani was trying to figure out, how the subsamples might have been oriented, right, as part of the analysis. Now, this is important because this could shed light on why those results don't line up. So imagine that the discrepancy was due to some kind of spatial effect, some kind of effect that would be different in different areas of the cloth. So imagine, for example, the problem were due to improper cleaning, like a gross mistake in cleaning. Like there's like big blotches of grease or something that just weren't treated, right? Well, how you cut it would make a big difference depending on like which ones got the grease, right?
Right, because if you cut the sample, one has a bunch of grease in it, and you test that one versus the one that doesn't.
Versus if you cut it in such a way that all of them had about the same amount,
right?
You know, so those orientations would give you very different results, right?
And want to emphasize too that the reason that we're going into this specifically is because Shroudis will use the fact that there is a line to say that this is evidence that we can't trust the data from the carbon-14. Right.
So to this end, Riani et al., they tested a whopping 387,072 configurations of the samples, different possible ways to shuffle them around to see how different subsample configurations would affect their data. So if Oxford did this versus whatever, right? Along the way, they actually found, or they concluded, that Arizona, even though they were given 2 samples, they only tested 1. And the reason is they got like crazy outliers whenever they used both samples, but not when they used just one. And before they published, they got correspondence from Professor Joel at the University of Arizona who said, yeah, we still have that other piece. Actually, we never used it. So, which was a surprise. That wasn't like widely known. So it's a good confirmation of their methodology. Specifically, though, there were several interesting conclusions that this paper came to. One, there is a significant effect in the vertical direction. By vertical, I mean going from top to bottom, going like from the edge of the shroud towards the center, through the different labs. Okay? But not in the other direction, not like going horizontally across all the labs at once. That's not too surprising because the sample is long and skinny. So if there's effect, it would show up better in the long axis anyway, right? So that's not surprising. That means that there was some kind of real effect that led to a discrepancy, particularly between Oxford and the other two labs. There's something going on that's not just like every lab's going to have some amount of error, and their results are never going to perfectly line up. But this is beyond that. This is such that those results can't be put together. So the word for that is that they're heterogeneous or not homogeneous. So you can't just simply combine the measurements together, or you could, but if you did, that wouldn't be representative of the actual average or the mean of the data you're doing. It would be improper.
Right. Because ideally what you would do is you would send them to 3 independent labs. They would all have the same testing protocols and everything. They would all give you results, and then you would take the average of all 3 if they were homogeneous. But because they're not, we can't just do that.
Right. And another way they could say be non-homogeneous. And this is not what happened in the Shroud, but just to explain how it would work. Is suppose 2 labs tested the sample you gave them, and then the 3rd lab tested some dude's t-shirt by mistake somehow. Well, those results would not be homogeneous. You'd get results and you could put them together.
Right.
But they would not tell you anything about your actual sample, right? They would not be homogeneous. Now, this is critical. In section 5 of the paper, though, it says this: the trend, the thing we just talked about, the trend from bottom to top, this error, the statistical anomaly. Quote, the significance of this trend does not depend strongly on the spatial allocation of the samples within the sites. That means in their analysis, it actually didn't end up mattering very much how the labs did their subsamples. What mattered was which subsamples belonged to which lab. So basically, who tested it, but not, and by extension, the rough kind of like location, but not where within the location the samples were. Okay.
Right. Because if they're picturing like a linear thing, then you would expect, like, let's say, for example, the bottom left corner up to the top right corner, then the sample in the here, middle, there would show a line. But if you were to flip-flop and do the other way, you would expect a completely different. And what they're saying is it didn't matter which way. It was just like this, stacked. That's how it mattered.
Right.
Yeah.
This is extremely important, and I haven't seen anyone else talk about it. So just to make sure I wasn't wrong and like completely off base in my interpretation, I actually reached out to Dr. Riani, who is one of the authors, and I asked him if I was understanding correctly. And in the interest of transparency, so nobody gets the idea that like Riani like read our episode and is like signing off on everything we said, I'm going to read you exactly what I asked him, and I'm going to read you what he said in response, so that no one gets twisted as to what Riani thinks or whatever. Okay, so here's what I asked in a larger email where I thanked him for his time and et cetera, et cetera. But the actual question was, am I understanding?
You mean you just in that email? Hey, what's the answer to this question? Thanks. Bye.
Hey, douche. Give me this answer. No, of course not. He was very polite and kind and gracious with his time.
Yeah.
So I asked him, am I understanding this correctly, that the specific spatial arrangement of the samples within a single lab did not end up mattering much? In other words, the effect of apparently younger ages in the X1 dimension, and X1 is the one going vertically, didn't depend strongly on whether, for example, Oxford cut their samples into rectangles 3 in a row, 3 in a column, 2 side by side and 1 stacked on the others, etc. So that was my question. About a day later, so very quick turnaround time, actually, he responded, and this is an excerpt from a larger email, but here's what he said. This is just to confirm that you understood perfectly well. The effect of apparently younger ages in the X1 dimension does not, in all caps, depend on whether, for example, Oxford cut their samples 3 in a row, 3 in a column, 2 side by side, stacked on the others. The main conclusion of the paper is that the overall sample is not homogeneous, and in presence of a trend, in technical terms, a non-stationary process, you cannot combine single measurements into a unique measurement. In other words, you cannot compute a mean. Or better, you can, but it is not representative of the underlying mean. Of course, I am a statistician, and therefore, I can only state what the data tell me, and I cannot claim anything about the reason of the trend. However, the statistical evidence is that there is a clear trend in the horizontal direction. That's what Riani said. So everything before that and everything after is my interpretation, not Riani's opinion. Okay. However, my interpretation of what he said and the paper.
Just pause for a second. We're always talking about going to actual experts to ask questions. And some people can feel intimidated by that. But Jordan had a really great conversation. It was cordial. He was polite, was happy to answer the question. So, like, don't be afraid to reach out to people. The worst that they could say is piss off. Like,
Right.
Or not respond. Yeah.
I've reached out to several authors. I don't always get a response, but it's generally, if you're polite and your question is reasonable and you're clearly showing an interest in the work, most of them are just overjoyed that somebody read their paper and are happy to explain. Like, they're not going to like teach you a full class, but they're happy to answer a question or two generally. So just be nice
and be respectful of their time.
Exactly. Right. Exactly. So based on all of that, his response and my understanding, here's my interpretation of what this means.
Not Riani's opinion.
Okay. Correct. As we look for explanations for this data, this would be disconfirming evidence of anything that is spatial in nature. Remember that grease stain from before? And that would be because it doesn't matter how you orient the samples, what parts were part of which sample. It was just a global trend. So, for example, imagine you supposed that this trend is due to a patch. Like they slapped a patch on it. Some of it's original Shroud of Turin, some of it's new stuff, right? You would expect that to matter a lot how the samples were oriented, because that would determine how much patch they got versus not patch, right? And so you'd expect big jumps in your subsamples depending on whether it was over here where all the patch is.
You got a big chunk of the new material from the patch over here, but you didn't over there. Right. You would expect it.
I know it seems like we're beating a dead horse, but this is like extremely important and is going to come up constantly over the next few episodes. It is vital that you understand this, okay? But after all that, the results for the other three samples, the other samples of known age, the controls that they gave to the labs, all of those meshed well. All the labs agreed on those, right? And so what that tells us that there is a problem, but it's not due to some systematic difference between the three labs that has nothing to do with the shroud. In other words, the effect has something to do with the Shroud of Turin itself, not just the labs. There could be a difference from the labs, but only if that difference is relevant to the shroud. Okay, so for example, suppose the shroud had a particular kind of stain that the other samples didn't have, and this stain was not cleaned up very well. That would be an example of something that is intrinsic to the cloth, not purely the labs. Okay?
Gotcha.
So, since this paper, the Riani et al. Paper from 2013, since that paper was released, the raw data from the labs, after a lot of fighting and Freedom of Information Act requests, they've been released. And other papers have like done deep dives on like the exact margins of error and should they have done this versus that and all that sort of stuff. None of that significantly changes the conclusions of the Riani paper. Like, it's all important stuff, but the basic thrust of it you can get from Riani. So we're not going to go into the noodly weeds of all because it's just not important. Okay. So what do we make of all this? What can we take away from the radiocarbon dating given all this? Well, first of all, it is flawed. Definitely there is some kind of anomaly. So that means we should be cautious in how we use these radiocarbon dating results. If you're interested in exactly when the Shroud of Turin was made, like in that range, was it 1230? Was it 1300? I don't think that you can use this test to tell you that, because the labs don't combine. It's flawed. You can't tell you with that level of precision. But before you celebrate too much, though, that is not to say that you can just ignore this data as if it didn't exist, right? Because all three labs, at the end of the day, detected enough radiocarbon such that the sample they said was 14th century, right? They tested it solidly in the Middle Ages. Every sample, every subsample had enough radiocarbon to be a medieval artifact, right? So they had way, way, way too much carbon-14 to have been from the first century.
Gotcha. So if we go back to your ruler example, where you're trying to measure a meter stick, and one ruler gives you one gives you 1.1 meters, one gives you 1.2, your stick is still around a meter.
Right.
And that's
you
what
don't
you're saying
know
here.
Whether it's a meter or 1.1 or 1.2, or maybe even like 0.9 or 1.3. Like,
sure,
maybe there's some kind of problem there. But you can probably be pretty confident it's not like 0.01. Right? Like the test would have to be extremely flawed for that to happen, right? And so this radiocarbon, the C14, didn't come from nowhere. Right? It is a thing they actually did measure, and its presence has to be explained if you want to maintain that the Shroud of Turin comes from the first century. Now, there are explanations that have been put forward that could explain the radiocarbon dating that we have and it being first century, but we'll see whether those actually hold up. Now, to test my own understanding, again, reaching out to experts, I happen to know a geochemist, Age of Rocks on Twitter. He does radiometric dating all the time. He doesn't do carbon dating specifically as much, but he does like radiometric dating is like his bread and butter. It's what he does all day, right? And so I asked him to like look over the papers. This is last time we did it. I asked him to look over my conclusions and just like, am I completely off base in this? And his impression was that they're making a lot out of very little. If this was any other sample, people would be stoked to have this level of agreement and would be fine. Like he said, these results are problematic if you need to narrow it down to a decade, but there's no chance the fabric isn't medieval. He said it would be better if you could test it another piece of cloth to like get a better answer. But if your only question is this first century, then you don't need any more tests. The answer is no. So there. Okay. So you now have a full understanding of the radiocarbon dating, its flaws, what it is and what it isn't. So let's summarize those real quick right here at the end. These are the facts that any explanation has to address. And we would prefer an explanation that fits them without stretching and requires the least amount of like ad hoc mechanisms in order to explain it. So, number one, the samples tested by all three labs contain sufficient carbon-14 to yield radiocarbon dates indicative of a medieval artifact. Number two, the Arizona sample, which was the closest to the center of the shroud, tested slightly younger than Zurich, but the results overlapped. The Oxford sample, which was the furthest from the center, dated slightly older than the other two, and their results did not quite overlap. They were very close. Fact three, all three labs tested control samples of known ages, and those results agreed with each other. That indicates that whatever effect is causing this, it has something to do with the Shroud of Turin itself. It could also have to do with the labs, but the Shroud of Turin is important for the explanation. And per Riani et al., the effect is statistically significant, but does not depend on the configuration of samples within each lab. So the position of where a sample is inside the lab's area is not strongly important, but the position between the lab's samples is.
So when we're going into our next episodes to cover it, as a result of this, people have said, well, we can't trust this data, or if they are accepting the data, they come up with reasons why the shroud is still first century, and this would be an explanation why the carbon-14 is such, right?
Yeah. So you can say, okay, here is an alternative hypothesis that explains this data, and that's fine. We can examine the hypothesis. That's a conversation we have. What you should not say is, well, it has flaws, therefore I'm going to ignore it. That is not justified by the evidence. You need to explain it somehow. You can explain it in a way that still lets your artifact be first century, but you have to explain it. Okay?
And that's what Shroudis have done, and we'll kind of get into.
So moving from here, what we'll be doing is we'll be taking this episode. We're going to assume that you, as good skeptics, have watched this episode and understood it, and we're going to then kind of test each hypothesis against these facts and see which one best explains the data. So bookmark this if you need to. If you need to keep going back, obviously, write a comment to yourself if you want to like put a reminder or whatever, so that you can have this touchstone back to these list of 4 facts, because it's going to be important moving forward. But you've made it to the end of the video, and that means you get a special treat. And we've been kind of running out of steam on the fallacies of the day. There's only so many fallacies, and like,
and we've covered a lot of them.
We've covered a lot of them, and so we decided to kind of mix things up. We're going to talk about a bad argument, the bad argument of the day. This one comes from people in our comments. Doesn't have to be, but this one did. So you can see there's 2 comments that I pulled out from just so many, you guys, just so many. And what they're saying basically is that there's $1 million reward for anyone who can recreate the Shroud of Turin, like show that how it was made. And so if we're so sure, we should just go claim this $1 million reward. Why don't you do it? Oh, you won't do it? Well, I guess it's real then. Like, that's the argument.
Yeah. The argument, if you can't recreate the Shroud of Turin now using modern things, then it's obviously a first century artifact. Yeah.
Not just like the royal we, like, no, you two idiots on YouTube, you two guys, you can't do it. And if you did, there's $1 million in it for you. And the fact that you won't go for that prize shows it's real. Like, this is the kind of stuff we hear about. And when they say this, like, I've even asked some of them, like, do you not understand how money works? Like, are you like independently wealthy? That's the only thing I can think of. Like, there's just all these like rich socialites who don't have to work for a living who are watching our YouTube channel and commenting this because they seem to have no concept of how finances work, right? Like, think about it. Suppose I decided, you know what? $1 million does sound nice, right? That'd be cool. So I'm going to claim this prize. First of all, there is a person at the other end who has that $1 million, right? And I have to convince them that I have done this to their satisfaction such that they will actually pay me this $1 million. And basically the only thing I have to go on is their word that, trust me, bro, I'll do it. Because there's no contract. I don't have a contract with this person. So like, it's
on YouTube, so that's binding.
Right. I mean, they've said they will. They put out statements, but like, I basically have to convince them, and then they have to hold up their end of the bargain. So like, there's that, first of all. But okay, let's say that they're saints and they're definitely like reasonable people or whatever. Well, I'd have to quit my job, probably go back to school and like get relevant expertise needed to like recreate an ancient textile.
Textiles, you got to do weaves, you got to do a loom, you got to learn how to do some sort of art or something.
And I'm not artistically inclined to begin with. Then I have to have access to all this lab equipment that I don't know where I'm getting that. That stuff isn't free. So I have to get all this lab equipment and probably hire other experts to like go do their parts of this thing. And then once I've got all that together, I have to then spend however much time it's going to take me to figure out how to recreate the Shroud of Turin, right? And then at the end of that, hope that I get $1 million, maybe? Like, this is going to cost me more than $1 million by the time we're done.
Yeah. This argument is crazy. I was listening to a talk show where people call in, and it was a very similar thing. Well, I had a $10,000 reward up and nobody was able to claim it, and so therefore I'm right, is the whole thing. I'm like, that's not how this works. Like, just because two idiots doesn't mean that it's authentic. And we are calling ourselves idiots. But you know what you can do, Jordan? You can make a table runner that has a Shroud of Turin on it and put it on your Thanksgiving table and eat dinner off of it.
Now that I could do. So once again, if this is merch, and we're joking, I am dead serious. If enough people comment that they would actually buy this, maybe I'll put up a poll. If enough people actually want this thing, I'll do it. We'll find a way to make this merch happen if you guys want it. So let us know if you want to do that, and then make sure you subscribe, hit the bell so you'll know the next episodes that are forthcoming. We don't know exactly how many there'll be. We don't want to rush it. We want to give every hypothesis sufficient time to like fully vet it so that we can have this done. And when we're done with these episodes, the Shroud of Turin will be solved, and we'll never have to talk about it again. Right? Right.
Nope. Right.
Yeah. Okay, so do all that and stay tuned. But remember, until next time, you've always got reason to doubt.
Peace out.